So, we started off doing integer exponents yesterday, now moving on to rational exponents, meaning that we have fractions in the exponent. Yeah, this is a little more complicated than yesterday. So, punch in your calculator, the square root of 5 times the square root of 5. What do you get, Carter? 5. Do you agree? On the other side, punch in 5 to the power of 1/2 times 5 to the power of 1/2. Minus this, we also get 5. Is everyone able to do that in their calculator? No? Okay, if you're not able to do that, you need to call me over after we do this lesson so I can show you how to do it on your calculator. It's going to be important. So these two things are equal. So that's going to help us out. What do we notice the index is in A? The index is 2. Tough to see that to 2. Which also lines up with the 2 in the denominator of our rational exponent. It's not a coincidence. So whatever this index is, would match up with this denominator here. So the meaning of 5 to the power 1/2 is what? If we were to put it in simplest terms, square root of 5. So just like yesterday, we don't leave anything with negative exponents. We now never leave anything with rational exponents. So if you have 5 to the power 1/2, it says simplify, you have to change it to look like that. How to do that? So, we have a law that we're going to work our way towards, but I'll give you that hint every time. It's different with these ones. It's the same pattern. What's 2 cubed times 2 cubed times 2 cubed equal to? Is that your calculator, Jay? Give it a shot. 2? No, cube root of 2, sorry. Cube root of 2 times the cube root of 2 times the cube root of 2 should be equal to 2.
I don't. I get the first one.
Okay, not everybody's done it, so what's 2 to the power 1/3 times 2 to the power 1/3 times 2 to the power 1/3 equal to? It's also equal to 2. We see our connection again. What are our indexes on this one? Our index is 3. What's our denominator, the number on the bottom? It's also 3. So what's the meaning of 2 to the power 1/3? Cube root 2. Yeah. Meaning that we have this beautiful, I think the next slide actually shows you it. This beautiful law right here. All these laws. I'll explain the letters. Dawson, move up here. Johnny, move there. Right here. Empty desk. Go. Hurry. Yes, Lynn. Yeah. The letters mean what, Joe? Yeah, it's just representing numbers. So A could be any number, M could be any number, and N could be any number. What it's saying is, if we had an example like this, to the power of 3 over 5. This first number, the 2 is going to stay there, right? The 2 is not what we need to worry about. We need to worry about the rational exponent. 5 goes there. It's your index. And this 3 goes, you can still stay right there. The example shows the 3 coming outside the brackets. That's the first way. The second way shows it inside the bracket. So it'll give you the same answer. Joe.
So on like these things, if the letters are matching, are they the same?
Yeah, so if the letters are the exact same, they match up. So that's what we see in our example here. We have this N right here is the same as this N right here, right? Yeah. So your index is your denominator of your rational exponent, the bottom number. Any questions about that? That's all we build off of. So they've made it a little more confusing than they've made it negative on the next law. What do we do with our negatives? Anybody remember from yesterday? Michael?
So, got rid of the brackets.
For this one? Yeah, I got rid of the brackets. So if we do like this way, the negative exponent did what to it? You put the entire power underneath, really in the denominator. So this negative right here, it's not just in the board, it's a little more clear on your sheet. That negative that's right there, to get rid of it, you put the entire thing underneath a 1. It goes on the other side. That's our negative exponent law from yesterday. And if it was on the bottom, then it would all go to the top, right? So it's the exact same stuff we did yesterday, but now it's a little more complicated because we have a negative rational exponent. Any questions how that happened? After you move it, then it's just the same law from above. So you move it all under, use the same law we just learned. So let's do a couple examples. Part of the power of 1/3. We want to simplify it. What would it look like? 3/r. The bottom number becomes your index. The top number is what you raise it to the power of. R to the power of 1 is r, so we leave it. What would this one change to? Yeah, you're right, Murphy. So it's the 7th root of s to the power of 4. Nailed it. T, a little more confusing. It's a negative rational. So what's the first thing we need to do? We want to get rid of that negative sign, so we're going to rewrite this as 1 over t to the power of 1/6. So just get rid of the negative. It becomes 1 over t to the power 1/6. The negative is now dealt with because we've moved it to the bottom. And now how do we solve that rational exponent on the bottom? Sure. Yeah, no, you're right. You had a tough time describing it, but you're right. It's 1 over 6th root of t. So the 1 over is still there. 6th root of t. His denominator was 6, so now his index is 6. It's still all underneath 1. Aiden, can you just sit there for a little bit? We had to move some people around. We'll get back after. We'll figure it out. Sit there. Joe's got it. Thanks. He took good care. Yeah. He's precious. He's kind of creepy, by the way. Okay. V. What's the first thing we have to do? Or sorry, P. P to the power of 3 over 2. What's the first thing we do?
Get rid of 1 over.
Yeah, 1 over. Get rid of the negative by making it 1 over. So it becomes 1 over b to the power of what? 3 over 2. Yeah. And then convert the denominator. How do we get rid of this denominator so we don't have it in a... Yeah. So it becomes 1 over she square rooted b, or sorry, she rooted the b, square root of the whole thing. The top number was 3, that still remains. She got rid of the bottom number by making a square root. Pretty simple. I'm going to do these ones above again. I run out of space. Yeah, there's an extend the page button. Yeah, there's an extend the page button, and I need to push it more often. Yeah, question, Johnny. Yes. Okay, so for this one, what is different about it? There's a 5 in the front. We have a coefficient. Does that actually change anything? No, because this 3/4 only applies to the t. So let's run through it quickly. The 5 remains. It's t to the power of 3/4. Just deal with the 3/4. It will become 5 4th root of t cubed. The next one, though, the 5 is affected. Why is it affected? Right, it's inside the bracket. So we need to apply this 3/4 to both the 5 and the t. To do that, we go 5 to the power of 3/4 times t to the power of 3/4. That's our law from the very first day. When we have something that's to the power of it, you multiply the exponent. So we took this 3/4, we applied it there, and then we applied it there. They were both just to the power of 1, so 1 times 3/4 is still just 3/4. This is equal to, what's the 5? We don't leave it as a rational exponent, so how would we rewrite it? Treat it just like it's a variable. Joe. It would be, so we have to get rid of the 3/4, right? On the 5. So treat it the same way as if it's, now it's a number, it used to be a letter. It's the same way. So what does the top number tell us? In the rational. Right here. Yeah, the 5 is still to the power of 3, right, Murphy? The 5 is still to the power of 3. And what did we do with the 4, Murphy?
You turn it into the index.
You make it the index. And then what do you do with your t? Exact same thing. So you have the 4th root of t. Try that in your calculator. Try the 4th root of 5 cubed and tell me what it gives you. And hopefully we don't get too many different answers. 3.34? Anybody else agree?
Yeah.
Carter? Yeah, 3.34? That's perfect. So we don't change it to decimals, right? We just leave it like that. If it had come out to be a whole number like 6, then you would simplify it to 6. If it asks you to simplify something to a 10th or 100th, then obviously do it. Alright, last one. Negative rational exponent. Johnny, how do we get rid of this negative? By putting a 1 over it, right? So it becomes 1 over negative z to the power of 5 over 3. Since Johnny flipped it all to the denominator, the negative on the exponent is gone. Now what do we do, Colton? Yeah, so which is the index? Which number is going to be our index? 5 or the 3? The 3. The 3rd root of negative z power 5. Yep. Any questions about this rational exponent law? It can get confusing in a hurry. No questions? Yep. Try to get those notes down. So what we're going to start seeing is questions that combine the negatives and the rationals, and then also combine our laws from the beginning. So you're going to be doing addition and subtraction of rational exponents, which are also negatives. Dawson. When only the numbers are negative?
Yeah, like say the C was only negative in the 5, like that was pretty good.
So this was negative, and that negative sign never existed?
Yeah, because,
yeah, so the negative Z, or negative Z, you want to call it, wouldn't change, right? We don't mind if our numbers are negative. It's when exponents are negative that we have to deal with it. So that negative didn't exist. We would treat it the same way that we did that question. The negative Z doesn't matter because it's a base. When the negative's on the base, we're good. When the negative's on the exponent, we have a problem. Michael.
what if you have
A negative denominator. That's a great question. Because we actually had that come up as one of our answers somewhere else. So, this. Let's say negative 1/2, right? It's the exact same thing as 1 over negative 2. Both are negative 1/2. So if the negative's on the top or if it's on the bottom, it won't make a difference. You might also see it written as negative 1/2, where it's on the entire thing. They're all the same. All three of those things are equal to negative 1/2. All right, next page. I'm going to go a little quicker through the examples, and then we have to evaluate. So we're starting to combine things now. Denominator is 2, numerator is 3. So that simplifies to the square root of 25 cubed. To evaluate without using a calculator, you need to think about what 25 to the power 3 is, and then think about its square rooted. That's a tough one to do in your head, isn't it? No? You can do, right, because you just love this. Yeah, okay, we'll catch you up. You don't have to do the cube part first. So you could actually do the square root of 25 first, and then cube root it, and we can do that in our heads, right? 125, because the square root of 25 is 5, so then it becomes 5 cubed. 5 cubed is 125. So the point of that is showing you that you can do either one first. You can do the square root first, or you can do the cube first. Let's jump to this one. This one mentally evaluates to be 3 is our index. Negative 8 squared. This one we're going to do the other order. If we had 64, negative 8 squared is 64. What would the cube root of 64 be? Stop. 8, the cube root of 64? The cube root of 64. Okay. 4. So you can square the negative 8 to give you 64, then the cube root of 64. Or you can do the cube root negative 8 and then square. You're going to get to the same spot both ways. This one simplifies. That's our index, the 4. Negative 3, I didn't deal with it yet, right? So it has to go where? On the bottom. So it becomes 1 over and miss that negative. And if it was already, if it was like that, then you just put it all to the top. It goes both ways. The 4th through to 16th, mentally. 2. And then 2 cubed is 8. That's answer. The last one, we need to use bed mass a little bit. What we have to do, what's inside the brackets first. B squared is 9. 4 squared is 16. That's all to the power 1/2. Still doing inside the, yeah, Mark. 1 over 8, yeah, you're right. Still 1 over 8. Still working inside the brackets. 9 plus 16 is 25. 1/2. The 2 becomes your index, which means you're doing the square root of 25, which is just equal to 5. These are questions you should be able to do mentally. No calculator. Are we going to move on? Okay, next page. How do we determine the side length of a cube? This is a review from other parts of the unit. How do you do it, Josh? You cube root the volume. So, cube root 125. That's the side length of a cube right there. That easy. Determine the surface area of the cube. A little bit harder. Use the information you just calculated. We know that this is one side length. So what do we do, Carter? Got it? This is equal to 5? 5 meters, yeah. So what do we do with that? We know one side length. How do we find the surface area now, Carter? Yeah, length times height or length times width. Either way, that'll give you one surface of the cube. So we did 5 times 5. And what do we have to do? That only gives you one side of the cube. Times by 6. That's length times width. Or times height, which is what Carter said, depends how you just want to visualize it. Times the number of sides. Meters plus square. Any questions? Cube has a volume of 60. Create a power radical that represents the edge length of the cube. So you have to do both. You have to write it as a power and write it as a radical. Write it as a radical first. How do we find the side length of a volume of a cube? Take the volume, cube root it. That fulfills this part of the question. Now you have to write it as a power. How do we write it as a power? Now we're converting it the other way. We want this to turn into 60 to the power of something. We've always been going the other way. Now we gotta go this way. How do we find out that's something, Emma? 1/3. How did you figure out it was 1/3? Yeah. So all she did is she knew we were aiming for a radical exponent. And she took this right here. Took that. And she knows that it came from her denominator. And then she just left the exponent. What's the exponent on 60? Right here. Exactly. it goes there. If there's no exponent, the exponent's 1. That's going the opposite way. Any questions about that? Pretty simple. It's just going backwards. We write a radical which represents the surface area of the cube. Radical means this form. So, cube root of 60 is one side length. And Carter gave us a hint last time. How do we do the surface area? That gave us our one side. So if we're writing something as a radical, leave it in radical form. You don't need to simplify it. You don't need to change it into a decimal. So if this is one length, what do you multiply it by? You square it. Yeah. You multiply it by itself. You put the square in there. And then what do you do? The last part. Now on your quizzes and your assignments that are about to come out, you would need to simplify that even further. You have to write it as a mixed radical, as simplified as possible. We've done a lot of practice on that, Tony. If you need more practice, you can look at your booklet or look at your next assignment coming up. So this is exactly what we just did. It's going in reverse. Get it?
Yes, please. Like, if you're calculating, you put like an exponent. What people specifically feature exponents. How do you get this?
Push this side up. Right. It should bring it back down. Does that work? I'll come check it out after it shows. It should work. Okay, so now we're just doing it the other way. If we want to convert that into a power with a positive exponent, what's our denominator? This part stays the same. It came from there. That part came from there. So if we follow the same theory for this one, what will our answer be? B 2/3. Same theory. That right there, that right there. Next one. Same theory. What do we get? Positive exponent. You're right. Leave it positive though. So this part down here has to stay underneath 1 because we're going to leave it as a positive exponent. So it's 1 over a to the power of 7/2. That is the top part. That's the bottom part. Okay. A. Seven. So right there. It remains on top. That 2 that's supposed to be here, that's your new denominator. A to the power of 7/2. I can't write it so I'll look like a power. Pardon? It'd be positive. I see where you're thinking it'd be a negative, and that's going to be a common mistake. You're going to think that this should be negative because it's underneath a 1. But just because it's underneath the 1 doesn't mean it's negative. It would be what Aaron said earlier. If you wanted to put this all to the top, then it would be negative. And that's why he gave an answer of a to the negative 7/2. But we want positive exponents, so leave it underneath. You don't need to change it to a negative. Alright, final one. What do we do with the coefficient? It just stays there. It's not attached to that radical sign. So you don't do anything to it. What do you do to the h? It stays here. You don't need to move it. You can put it in front if you want, if you like the letters first. Most commonly in math, your coefficient, if it's a number, goes in front. The variable always goes after. What do we do for our exponent? Jared, do me a hint. 3 goes on top. The 4 goes underneath.
No.
That?
No.
No, you said it right. I did it backwards. You said the 3 goes last. The 3 goes underneath. So the 4 stays on top. The 3 goes underneath. Any questions about converting this way? These are the types of questions that you're going to see at the end. So this is as hard as it gets. We have multiplication here. For those of you who missed the first couple days, this is the stuff from the very first day, so it might be super confusing. What's our law say when we multiply two things with the same base together? Add the exponents. So we have x to the power of 3 over 2 times x to the power of 1. Can you add 1 and add 3 over 2? No, we're going to have to do a crash course on common denominator. 3 over 2 plus 1. You can't add things together unless the denominator is the same. The denominator here is just 1. To get the denominator the same, you have to multiply everything in here by that denominator. And that'll give you a new equation that'll look like this. 3 over 2 plus, you multiply the top by 2 and you multiply the bottom by 2. 2 over 2. Now you can add these together. When you add exponents, you only add the top numbers. You don't add the bottom numbers. Think about it if it was like candy or something. If you had 3 halves and then you added 2 more halves, you wouldn't have to add the bottom and divide them again, right? You're still getting halves. So it's just 5 over 2. And that's what our answer is. What's our quotient law? Subtracting. When we have 2 bases that are the same and we're subtracting, you subtract the exponents. So we have y to the 1/3 divided by y to the 5th over 3. You take 1/3 and you minus 5/3 from it. 1/3 minus 5/3 is negative 4/3. Yes, Matthew. Yes, sir. Negative 4/3. We don't deal with negative exponents, so what do we have to do? 1 over it all. So it becomes 1 over y to the 4/3. It does say that, doesn't it? Yeah, because we don't leave things with rational exponents, right? So we actually should have done that one too. What would we convert this one to for our final answer? We have to convert it to a radical. Josh?
Convert it to a radical with 5 as
The 5 is the exponent on the x, and the 2 is your index. So this one sloppily says 4 over 3. And Michael, what do you convert it to? Cube root y what? Yes. Getting the hang of this? This one's different. When we have power to a power, what's the law tell us to do? Multiply. How do we multiply 1/2 by 2/3? Yeah, transport on multiply. No. So that was addition up top. Works the same for subtraction. You have to have the same bottoms. For multiplication, it's a lot easier. 1 over 2 times 2 over 3. You multiply everything on the top, and you multiply everything on the bottom. So, 2 times 1 is 2 times 3 is. Multiplication's way easier. You don't have to get common numbers. You can just multiply them together if you get time. Simplify? Yeah, so what does that simplify to? Yeah, 1/3, which will make your life way easier. Just simplify it right now. Yeah. So, if we follow those steps, that gives us a to the power 1 over 3. We have to convert it because we don't leave things with rational exponents. What do we convert it to, Boris? Cube root of a. Okay. That's your final answer. Good if I'll erase this first part. D, we're going to do above. We have two things multiplied. How do we deal with the coefficients? Multiply them. 4 times 3 is x to the power of 3 over 4 times x to the power of 1/2. Negative 1/2, yeah. We'll do that up here. How do we do that, guys? We have two things the same base multiplied. What do we do to the exponents? This one's going to be a little harder, right? Because the numbers don't add up so nicely. So we have to add the exponents, right? That's what you're saying? So 3 over 4 plus 1 over 2. The bottom here is 1. So our trick is going to be a little bit more difficult. For those of you who can easily find a common denominator, go ahead and do it. The common denominator is whatever.
Oh, I was just
Yeah, sorry. Yeah. So it's actually subtracted, it's adding a negative, which is just a fraction.
so that's the one that applies to the four.
Yeah, it applies to the 1 and the 2. Yeah. Alright. Yeah. You need to find a common denominator. For those of you who see that it's 4, you can just multiply all that by 2. For those of you like me who just like the easy out, you multiply this entire one by 4, and then you multiply this entire one by 2. So if you multiply the left all by 2, you would get 6 over 8. And you multiply this entire side by 4, you get 4 over 8. And that gives you common denominators. I took this denominator, and I multiplied the second one, all by that denominator. Then I multiply this entire one by that denominator. Basically, you take each denominator and you switch which one you multiply by, and it'll give you the bottom of the b. Pardon?
So just cross multiply?
Yeah, it's just cross multiply. What does that add to b? It adds up to be 2 over 8. Or 1/4. So if you do it this way, like I do, you're going to have to simplify at the end. Those of you who did it the other way don't have to simplify at the end. So if it's x to the power of negative 4, sorry, positive 1/4. What's our final step? Keep the coefficient. Take the 4 cube of x. This one, guys, it's the same thing. You simplify the 5 into 25. 5 divided by 25 is just 1/5. The x's, you're just going to subtract each other. 3/5 minus 3/5 is like adding, correct? So the 5 divided by 25 is just 1/5. X to the power of 3/5 divided by x to the power of negative 3/5. You're subtracting a negative. It's just adding. So you can add those exponents to be 6/5. The 1/5 stays the same. We need to simplify that to be the 5th root of x to the power of 6. The last one, you're going to just take that and apply it to both. So take that exponent. I know this is a lot of examples, but there's a lot of different situations you guys are going to see. Two times 1/2. It's going to be x negative 1. And on the bottom, 1 times negative 1/2. I can give you y power negative 1/2. We have two issues here. We have negative exponents, and we also have a rational exponent. This one, yep, has to go to the bottom because of that. This one has to go to the top because of that. That makes it y to the power of 1/2 divided by x to the power of 1. Which is x. Yes, Weston? Yes. Rewrite the y to the power of 1/2. So it's square root of y over x. The square root only applies to the y. Yeah, we're almost there, Joe. We're almost there. I know it's a lot of examples. It's a lot of different situations that you see, right? Because there's so many combinations of laws, and we're trying to cover them all. So when you run into a problem, you have a nice notepad. These last ones. Write as a power and then evaluate. I'm going to speak really quickly just to get us through it, so you guys have some time to do some work. That is like to the power of 1/2 times to the power of 1/2. So it's the same as saying 1296 to the power of 1/4. Because this is like 1296 to the power of 1/2. Power of 1/2. That's what it's saying. You square rooted it and then you square rooted it again. Just multiply your exponents. That'll give you 1/4. So that's your final answer. This one is just 1/. To rewrite that one as a power is simple. 169 to the power of 1/2. It is saying to evaluate them, guys. I know you know how to evaluate them. You can try that on your own in your calculator. This one is the same as this, except instead of square rooting what you square rooted, you're cube rooting it. So you got 64 to the power of 1/2 to the power of 1/3. Square root, cube root. 64 to the power of 1/6. We multiplied our exponents together. These ones down here, radiation in the form of a x to the power of n. That means no root sides are allowed. To bring your 3 in, you need to go Cube root of 8 is just 2. So cube root of 8 times x to the power of 5 over 3. It says a, it doesn't say to use as a radical, so we have to change that to be 2 times x to the power of 5 over 3. Next ones are all the same thing. This would be 2 x to the power of 3 over 2. Or, sorry, 2 over 4. The next one, the square root of 900. No idea what that is. 30? X to the power. Whew.